Hey everyone, have you ever really thought about the mirrors you look into every single day? Well, there's a really curious bit of physics hiding in plain sight that honestly seems to defy all logic. It feels like a magic trick, but stick with me and I'll show you how some pretty simple science makes it all work. So let me ask you this. To see your entire reflection, from the top of your head to the tips of your toes, how tall does a mirror actually have to be? Now, your gut feeling, your logic, probably screams that it has to be your full height, right? I mean, how else could it possibly fit your whole reflection? But the truly surprising answer, proven by physics, is that the mirror only needs to be exactly half your height. That's it. So a 6-foot-tall person only needs a 3-foot mirror. So what in the world is going on here? How's that even possible? To solve this little mystery, we don't need any complicated formulas or high-level math. We just need one single, beautifully simple rule that governs how all light reflects. And here it is. The law of reflection. All it says is that the angle light comes in at when it hits a mirror is the exact same angle it bounces out at. Angle in equals angle out. Simple, elegant, and believe it or not, it's the only tool we're going to need. So just a quick reminder of how seeing actually works. You don't really see the mirror itself, you see the light that is bounced off an object, in this case you, which then hits the mirror and then reflects into your eye. It's just a simple 3-step journey. Okay, let's put that rule to work. We're actually going to trace the path of light from you to the mirror and then back to your eyes to build a visual solution. Let's draw it out. Let's break this down into smaller pieces. To see your full reflection, you have to be able to see 2 critical points, the very top of your head and the very bottom of your feet. So let's start at the top. For you to see the top of your head, a ray of light has to travel from your hair, hit the mirror at a very specific spot, and then bounce perfectly down into your eye. You can think of it like a bank shot in pool. And because that angle of light coming in must equal the angle going out, the geometry works out perfectly. That reflection point on the mirror has to be precisely halfway between your eyes and the top of your head. This right here defines the absolute top edge of the mirror that we need. Great, we've found the top of our mirror. Now, let's do the exact same thing, but for the bottom. How do you see your feet? It is the exact same principle, just in reverse. A light ray leaves your foot, travels up to the mirror, and reflects at just the right angle to enter your eye. And once again, the law of reflection dictates the geometry. For that perfect bank shot to work, the reflection point on the mirror must be exactly halfway between the vertical position of your eyes and your feet. This spot defines the bottom edge of the mirror you need. Okay, so we found our 2 critical points, the highest point in the mirror you need to look at and the lowest. Now we just put them together for the grand finale. So let's just quickly recap. The top edge of the necessary mirror is halfway between your eyes and your head. The bottom edge is halfway between your eyes and your feet. Simple enough? Now this is the crucial part. You don't need any mirror surface above that top reflection point or below that bottom one. The only section of the mirror that's actually doing any work to see your full reflection is the space right between those 2 spots. So let's put it all together. The required section of the mirror stretches from the halfway point between your head and eyes all the way down to the halfway point between your eyes and feet. And when you do the math, that total length is exactly half the distance from the top of your head to your feet. In other words, half your total height. Wild, right? Now, this is the moment where a lot of people ask a really smart follow-up question. They say, wait a minute, doesn't it matter how far away I stand from the mirror? If I back up, do I need a bigger mirror? And the surprising answer is no. When you stand close, the light rays form a wide triangle. When you stand far away, they form a narrow one. But, and this is the key, because the law of reflection is constant, the actual points on the mirror needed for the reflection stay in the exact same vertical position. So the geometry is absolutely unshakable. The rule holds. And the mirror you need is always half your height. It's a constant truth just hiding in every reflection. And just like that, we're right back where we started. But now it all makes sense. What felt like some kind of weird magic trick is really just a simple, elegant proof using geometry. So we've solved the how big question, but that leaves one final piece of the puzzle. Now that you have the tools, think about this. Where on the wall must that half-size mirror be hung for it to actually work? The answer is hidden in the very diagrams we just explored. Thanks for joining this explainer.